This is option 1 of your assignment, and it is probably the most widely defined one. In other words, you have more choice for this option than you do for the other options. Essentially, what is being asked is that you carry out weak form tests of the efficient markets hypothesis and present a report to the managing director of XYZ Limited. So, tests of efficiency is to test for randomness, because the efficient markets hypothesis says that over short periods the movements should be random. Well, you're offered 3 ways of doing this. You can choose one way. If you want, you can do 2 ways, but you do it over 3 currencies and over different time periods. That sounds a lot, but if you choose one of these tests and do it over 3, you'll have you won't find the task too great, shall I say. Right, the first way of testing for this I'm going to explain is the simplest one, and this is where you download the exchange rate from EIU, and I'll have a short video on that. And it outputs in Excel. In Excel, you calculate the percentage change as a fraction, of course, and then you cut and paste the data into Minitab. Now, to explain this runs test, what I've done is I've put in a dummy set of variables, and the default name for this is C6. So we have a dummy set of observations, and as you can see, they are clearly not random. So let's apply the Minitab test. To do that, we click on Statistics, Non-Parametrics, and Runs Test. And we want to run it for C6, so we click on that, select OK. And here we look at the printout for this test. The printout can be transferred to a project by clicking on the menu and selecting an option there. Picture is probably the best of them. The printout is saying you've got 7 observations, that's correct. The average is 4, that's what we would see, 3 below and 3 above, all equally spaced. The number of observations at or below the mean is 4, that's 1, 2, 3, 4, yep. And the number that are above the mean is 3, so 5, 6, 7. However, we're interested in runs because a run is an indication of non-randomness. Run is defined as the number of consecutive observations below the mean or above the mean. Looking at this, we can see intuitively that there are 2 runs. One run below or at the mean here, and there's 1 run above the mean. And this is what this is saying. The number of runs observed is 2. We can see that. The expected number of runs is 4.43. Right, so that we won't worry about the statistics of that. It's slightly off. Well, anyway, we won't worry with that. The probability that this is random, right, and that's the key thing, the probability that this is random is 0.039. In other words, it's a low probability that it's random, therefore it is not random. We can see by inspection that it isn't random. Okay, now let's apply the test to C4, and that is the one that we are interested in. So we apply statistics, non-parametrics, runs test, and we want C4, which is change. We select that. That's the change in our exchange rate, and we run that. So here we have the results for this exchange rate, the changes in it. 302 observations. The sample mean is virtually 0. Number of observations below it is 159. The number of observations above is 143. So the two added together come to 302. However, we're interested in runs because if we have consecutive observations below the mean, that suggests that there is some sort of pattern going on. The observed number of runs is 140. The expected number of runs was 151.58. That sounds like not too great a difference. However, we do have a lot of observations, so statistics is perhaps expecting quite a close difference between the two. It shouldn't wander too far away from what we expect of random movements. So the probability that it is random is 0.181, 18%. Now that is low, but it is above the 0.05, right? Remember the previous one was below the 0.05, it wasn't random. It is above 0.05, so we say that it is random. But it is not that far above 0.05, so it's random, but this isn't a conclusive test. There is no test that conclusively says this is random, because the set of random patterns is infinite, right? That you can invent one, like every Thursday of a month with an R in it, the exchange rate is going to increase. Well, no statistics is going to pick that up, but I don't think so. So the set of patterns is infinite. So in this case, we say, yep, it looks random, only just. Now, it's a relatively simple matter to look at sub-periods. You just go back to your Excel sheet and cut the data in half, or however you want to cut it up, and do separate runs tests. So it's just repeating this cycle. Okay, so that's the easiest of our options for testing for randomness. So now let's go on to our slightly more difficult one, but it's a bit more fun. And here we have this data downloaded from EIU, and as you can see, it is exactly the same pattern as was copied and pasted into Minitab. So actually, that's what I did. I did just copy and paste this into Minitab. However, we can do a test on this data called a filter test. I say it's more fun because you can invent a pattern and then test to see whether it's random or not. So what I have here is a test of a very simple pattern, and that is whether after 3 days of falls, what happens on the 4th day. Now, if I was to put this to a class who hadn't studied finance, people would say with great conviction, it's going to go back up, right? Or it's going to continue on down. Very few put up their hands and say, I don't know, which is the correct answer. So we've got the change, which we talked about before. That's the formula I use for change. You can use that minus that and divided by that, divided by the February one, if you want, but that's the one I use. How do we measure our pattern? Well, we use something called nested if instructions. If instruction you may or may not be familiar with, and it says if this condition is true, do this, if not, do that, and that takes you into another if instruction, and so on. So we have here our instruction, and it says if D17, which is this one, that one, D17 is greater than 0, and then this double inverted commas. That means put a blank, leave the cell that you're in blank. The cell that you're in is E17. So it says leave E17 blank. If it isn't greater than 0, and as we can see, D17 is negative, so it's not greater than 0, it goes on to this instruction. And this says if D18 is greater than 0, then put a blank in E17. So if we look at D18, we see it's not greater than 0. So we don't put a blank in, we go on to this, which is another instruction. And that is saying if D19 is greater than 0, then put a blank in E17. So we go to D19, we see that that is also negative. So none of these conditions are fulfilled because our changes in each of those particular months was negative. We have 3 negative months in a row. Therefore, it's saying if all that is true, then put D16 in the cell. So D16 is the following month, February. In November, December, and January, there were negative movements in the value of the dollar. What happened in February? It went up, right? It's going to go up or down. It went up in this case. And that is why we have the 0.019. If we look at another value where there's a blank, let's have a look at that. And that says if D16 is greater than 0, put a blank in the cell. If we go to D16, we see that it is greater than 0, and therefore it puts a blank in the cell and it's fulfilled the instruction. It doesn't go to any of the others because that instruction would have to be wrong for it to step into the alternative. So that is the nature of nested if instructions. What we have here are all those observations that are preceded by 3 negative movements. And you'll appreciate that if you want, you can put in more conditions. If you want, you can simply change these to less than 0 and therefore look at 3 positive changes. You can look at positive changes and negative changes. So, you've got a lot of choice with this option in terms of tests and what you can do within each test. These are the values. They are, as you can see, they've got formulas behind them. So what I've done here is simply to cut and paste the values and list them and order them. I then, I suppose, cheated a little bit and put them into Minitab because Minitab gives better histograms. You can use the histogram in Excel. You can probably make a better fist of it than me. I'll just pause and try and make up one from this data. Okay, this is the one from Excel. As you can see, it's the same data, but it does look a little bit different. I have, there's a little cheat you can do here. The bin widths, etc., are a little bit of a problem, and to get them to be regular, I just changed the very lowest one from being, I think it was 0.05847 or something like that. I've changed that to minus 0.06. So I've just changed it a little bit because the Excel system picks up the lowest one and then defines the bin width from the lowest one. So I took the bin width as 0.01, so you can see each bin is now a regular distance, whereas here it's perhaps not so well defined. Right, so I think the Minitab printout is kind of nice. You can put it in where the 0 should be. It should be distributed around 0. So I'm just going to do that. So I'll put the lines in for 0 here. Minitab, I assume it's there. And for Excel, it's this long number is in fact 0. It is 1.38 to the, I don't know if it uses E or something, but there are 16 zeros before you get to the, so it's point and then 16 zeros and then 1.38. So it's a tiny number. So that's really what it means by 0. For some reason it doesn't say 0. So anyway, that's minus 0.012 this number, which is 0. So 0 is here. These are above 0. These are below 0. And as you can see, and you can count them on here, there are rather more observations below 0 than above 0. What is this saying? And that is after 3 days of falls. There's a slight tendency for the next day to fall, but it is not a very great probability. I've just checked this column, and of the 58 observations, no, sorry, they're not 58 observations. I should have said of the 44 observations, 25 are negative. So 25 divided by 44 is 56 or 57% rounded. 57% of the observations are negative, and the 43 are above. So there is a slight probability favouring a negative movement for this particular sample. Now, to do it over a shorter time period or longer time period is relatively straightforward. To do it for a different currency, you just have to put in different exchange rates there, and the rest is done for you. So that is a second way of testing for randomness. And the final way is the variance ratio test, which we will now move on to. This is the last of our tests for randomness under option 1. The basic question is very simple. If you remember, binomial lattice predicts this kind of cone shape of movements if they are random at each point in time. So across here we have time, and as time passes, so the variance of our movements should increase at a regular rate. We've formulated this into a simple question, and that is whether 2 monthly changes, the variance of 2 monthly changes, is that twice the variance of a 1 monthly change? Simple question, and that's what we're answering here. So as with the last one, we have exactly the same exchange rate and change, and you can cut and paste into here, and all the rest will follow automatically. So we've got monthly changes here, and here we've got the 60 month changes. So that's the variance over a sample of 60 months. I don't know why I put days there. It's not days, it's months. Okay. And here we have the 2 monthly changes. Sorry, we have the exchange rate with a 2 month gap. Right? So, oh yes, that's right. I put the first one in manually, and the second one has got this kind of test to see if this is an even or an odd number, which is just a bit of fiddling around basically, and it detects that it's an odd number, and therefore it puts in the month. Right, so it's just part of the programming here, so don't worry about that. It does the job of selecting every other month. You don't really want to change that, it gets a bit fiddly. Now this detects the change over 2 months, so this is the 2-monthly change. So we can see here that this value of the dollar is slightly above that value, and therefore the change is positive. This value is below this value, and therefore the change is negative. So this is looking at this fractional measure of the changes. That's the change, and we want to know the variance of those changes. For that, we calculate them here with this instruction var. Again, all this gubbins here is to stop it putting an entry into the blank cells there. This is the variance over I15 to 74, so I15 down to I74, and as you can see here, these are the monthly changes from D15, the monthly change, to D74. So over the same time period, one is looking at 2 monthly changes, this one, and the other's looking at 1 monthly changes. So this ratio should be twice this one. As you can see there, in this case, the ratio is 2.49 and is considerably above 2, and then it seems to drop down. Well, the behavior of these ratios over time is an issue in itself. You can see that there are whole series where it appears to be more. However, what I've done is I've taken these values and pasted them as values. You go to the paste and you select the option that is just pasting values, and then I've gone to data and sorted it into low to high. And then I've done what I did before, cheated a little bit and just rounded that one to 1.5 so that the axis starts at a 1.5, and then defined bin width in the format axis as 0.1, and so we get a nice regular set of bin widths. If you don't do that, it's okay, it's just a little bit messier, that's all. It's not essential, but it's just a presentation thing, but which is important. But anyway, it's not fatal if you don't manage that. What are we seeing here? Well, we're seeing here that the ratio is usually below what we would expect, the 2. In fact, having just looked at it, about 80% are below and only 20% above the 2. So our average is going to be below 2. What does this mean? Well, we referred earlier to the cone shape that we would expect. Clearly that cone is not expanding. The ratio is below 2, and therefore the ratio is not going out as much as we would expect. So it's as if if we just go here, okay, so it's as if our cone isn't expanding by quite the rate we would expect it to expand, and therefore there's some sort of centering effect. If it goes up into this blue area, it tends more likely to go down than up, and if it goes down here, it's more likely to go up than down. So there's a kind of centering effect going on there. So that would appear to be the implication. So a slight non-randomness, but there's a kind of gap between something that's not entirely random with certain characteristics and something that you can trade on, which is a different matter. It has to be of a certain size, though quite what these algorithms are up to, goodness knows. So it has to be of a certain level of non-randomness for a profitable strategy to be possible. Okay, so that's the final one of our tests. You can do a variance ratio test, you can do a filter test, or you can do a runs test. You can do two of them if you want, but you need to do them across 3 different currencies, and a different currency is simply plugging these numbers in, putting a different currency into this column, and the rest is done automatically. You then have to explain and present the results. So there's potentially an enormous amount here. You can't do it all, so don't try, right? That's too ambitious. Don't be too ambitious. Concentrate on presenting what you do. Okay, so that completes our option 1.